Okay, welcome back to the deep dive. We're jumping into some really interesting source material you've shared with us today. We're focusing on something pretty crucial if you're building modern web apps.
Yeah, we're looking at the foundation of the MEVN stack. It's definitely an exciting topic, especially with the source we have.
It is. And the main source for this one is a book called Ultimate Full Stack Web Development with MEVN. And the subtitle is, well, it's long, Learn from Designing to Deploying Production-Grade Web Applications with MongoDB, Express, Vue, and Node.js on AWS, Azure, and GCP.
Yeah, quite the title, but it really lays out the whole journey, doesn't it? From the core tech, MongoDB, Express, Vue, Node, right through to getting it running in the cloud.
Exactly. And the author, Bhargav Bachina, seems like the real deal. The book mentions he's got over, 12 years in IT, known for leadership, software architecture.
Right, across the board, front-end, back-end, cloud. And importantly, he's deep into Node.js and JavaScript. Plus, the guy's written over 700 articles on Medium, or reached like 8 million people, and has hundreds of GitHub repos. He clearly knows his stuff.
Yeah, definitely walks the walk. The book's pretty fresh, too, published July 19th, 2024. And already the early reviews are really positive. Things like perfect guide for modern MEVN stack developers. And excellent resource for real-world projects. And they specifically call out that it covers production stuff like Docker and cloud deployment.
And that's key, right? Taking it beyond just theory and into actual deployment, that's super valuable.
Totally agree. But for this deep dive, we're going to zoom in right on the very beginning. Chapter 1, titled simply Introduction.
Makes sense. Chapter 1, based on the source, is all about laying that groundwork. Demystifying MEVN, introducing the core technologies, and getting you ready to actually use these pieces together. It's that essential first step.
Okay. And it looks like it breaks down into 5 main chunks. Understanding the MEVN stack itself.
Yeah.
Then separate intros for MongoDB, Node.js, Express.js, and Vue.js.
Yeah. Setting the stage, making sure you know who the players are and what roles they play before the game really starts.
All right, let's unpack it then. We keep saying MEVN stack. So what exactly is it? What's the acronym stand for?
Right. So MEVN is just MEVN, MongoDB, Express.js, Vue.js, and Node.js. The book presents it as, a really popular combination, a stack for building performant full stack web applications.
Okay. And the book stresses this JavaScript-centric approach. Why is that a big deal? What's the advantage there?
That's kind of the cornerstone, really. It means you're using JavaScript or languages closely related to it for pretty much the whole thing. You've got Node.js on the server, handling backend logic and talking to the database. Then you have Vue.js on the client side, building the user interface in the browser. And even MongoDB, while it's its own database, interacts very smoothly with JavaScript via drivers and libraries.
So one language to rule them all, sort of?
Pretty much. The big win is consistency. Developers can potentially work across the entire application stack using familiar syntax and tools. It can really streamline the development process, maybe even mean you need fewer specialists for different parts, makes things smoother.
Makes sense. Less context switching, easier code sharing maybe. Okay, so let's break down those letters, starting with MongoDB. What's its job in the stack?
MongoDB is your database, but it's different from, say, a traditional SQL database. It's a NoSQL database. Instead of tables and rows, it stores data in flexible JSON-like documents.
JSON-like?
Yeah, specifically BSON, which stands for binary JSON. It's very similar to JSON, but supports a few more data types, which is useful for database work.
Okay, BSON. Got it. So what's the benefit of using these documents instead of tables?
Flexibility is the huge one. With documents, you don't need a strict, predefined schema for everything up front. One document in a collection can have slightly different fields than another. This makes it really good for handling, large amounts of data that might not fit neatly into tables or data whose structure evolves over time. Think unstructured or semi-structured data. And it's known for being scalable. You interact with it from Node using libraries like Mongoose is a really popular one.
Flexible data storage, scalable. Okay, next up, Express.js. That's the backend framework.
Exactly. The book calls it a minimal and flexible web application framework, and importantly, it's built on top of Node.js. So it leverages Node's power, but provides a layer of tools and structure to make building the backend easier.
Minimal and flexible. What does that mean in practice? What does it do for you?
It gives you the essentials without being too opinionated about how you build things. It simplifies common web server tasks. Things like routing, defining how your app responds when someone visits different URLs. Also, handling request and response objects, parsing incoming data, sending back JSON responses for APIs, error handling. And a big one is middleware.
Middleware.
Yeah, middleware functions are like little processing steps that a request goes through before it hits your main route handler. You can use them for things like authentication, logging, data validation, lots of stuff. Express makes managing all this much cleaner than just using Node.js by itself. It's chosen for speed and scalability, building on Node's strengths.
Okay, so Express provides the structure and tools for the server-side logic.
Got it.
Now, let's jump to the front end. Vue.js. The source calls it a progressive framework. What's that about?
Progressive basically means you can adopt it gradually. You don't have to go all in from the start. You could use Vue to add some interactivity to just one part of an existing website, or you could use it to build a massive, complex, single-page application, an SPA. Its main role in MEVN is building the user interface, everything the user sees and interacts with in their browser.
And why Vue? What makes it a good fit here?
The book highlights a few things. Its ease of integration is one, makes it simple to drop into projects. Its reactivity is another huge plus.
Reactivity.
Yeah, it means when your underlying data changes, the parts of the UI that depend on that data automatically update. It makes keeping the view in sync with the state much easier. And it has a component-based architecture.
Like building with Lego bricks.
Kinda, yeah. You build your UI out of reusable components like a button, a user profile card, a navigation bar. This makes your code more organized, easier to test, and scalable for bigger projects. Plus, it's generally known for having good performance.
Okay, Vue handles the UI, makes it reactive, component-driven. Cool. Last piece, Node.js. We know Express runs on it, but what's its fundamental role?
Node.js is the engine that lets you run JavaScript on the server. Before Node.js came along, JavaScript was pretty much confined to the web browser. Node, created by Ryan Dahl, changed that. So in the MEVN stack, Node.js is the runtime environment for your entire backend. You write your server logic in JavaScript, you use Express within Node, and Node handles communicating with the database, like MongoDB.
And it has that specific architecture the book mentions, single-threaded.
Right, that's a core concept. Node.js uses a single-threaded event loop model with non-blocking I/O operations, which sounds complicated, but the key idea is efficiency.
How so? Single thread sounds like it could be a bottleneck.
You'd think so, but the non-blocking part is crucial. When Node needs to do something that takes time, like reading a file, making a network request, querying the database, it doesn't just stop and wait for that task to finish. It kicks off the operation and then immediately goes back to handling other incoming requests. When the slow operation completes, Node gets notified via an event and picks up the result.
So it's constantly juggling tasks rather than waiting in line.
Exactly. It makes it incredibly efficient at handling many concurrent connections or operations without consuming vast amounts of system resources like some other server models might. That's why it's so good for I/O-intensive applications like web servers, APIs, real-time apps. And of course, Node.js, through its package manager NPM, is how you install and manage Express, Vue libraries, MongoDB drivers, everything else.
Okay, that really paints the picture. Flexible database, minimal backend, progressive front-end, efficient runtime, all JavaScript. So who uses this? What kinds of projects really benefit from MEVN? The chapter listed quite a few.
Yeah, it's surprisingly versatile, according to the source. You see it used for e-commerce sites, content management systems, CMSs, real-time applications, think chat apps, collaborative tools, that kind of thing, where Node's event loop and Vue's reactivity really work well together.
What else?
Social media platforms, definitely single-page applications, SPAs, bigger enterprise web applications, dashboards, and analytics tools, even stretching into things like IoT applications, financial services apps, and streaming services.
Wow, that's a broad spectrum. Seems like that JavaScript everywhere thing really does open it up.
It does. The takeaway from the chapter is its high adaptability. It makes it a solid choice for a whole range of modern web needs, whether you're an experienced dev or just getting started.
Now, the chapter spends a bit more time specifically on MongoDB, and that comparison with traditional databases is interesting. Can you remind us about the core difference in how it stores data?
Sure. So again, instead of the tables, rows, and columns you get in traditional relational databases like your SQL Server, MySQL, Postgres MongoDB uses collections of documents. And these documents are stored in that BSON format we mentioned, which is like structured JSON. The key is documents within the same collection don't have to have the exact same fields.
Right, the flexibility. And the book mentioned its history briefly. It wasn't always this way.
No, it came onto the scene around 2009, part of that whole NoSQL movement. Back then, the big drivers were scalability and agility, needing ways to handle the massive, often unstructured data coming from web applications and big data scenarios. Initially, it might have been simpler, but it's evolved a lot. They've added really powerful features over the years, like a sophisticated aggregation framework for data analysis within the database, and even AC transactions.
AC transactions, isn't that usually a SQL thing?
It traditionally was, yeah. ACID compliance guarantees reliability for database operations. MongoDB adding support for multi-document ACID transactions was a pretty big deal, making it viable for a wider range of applications that need strong consistency guarantees.
So it's definitely matured. What are the other standout features the book highlights?
Well, besides the flexible document model, scalability is huge. It's designed from the ground up for horizontal scaling using a technique called sharding. This means you can spread your data across many servers easily as your application grows. Contrast that with traditional databases that often scale vertically, meaning you just buy a bigger, more expensive server.
Okay, horizontal scaling.
Yeah.
What else?
High performance is another. This comes from features like robust indexing options, built-in replication for high availability and read scaling, and an efficient query engine. And that aggregation framework is really powerful. It lets you define multi-stage pipelines to process data, do calculations, and return computed results all within the database.
That comparison table in the source between MongoDB and traditional SQL seems super helpful for deciding when to use which. What are the main contrasts it lays out?
It really boils down to a few key areas. First, data structure and schema. SQL is tables, rows, columns with a predefined fixed schema. MongoDB is documents with a flexible dynamic schema. Then query language. SQL has, SQL, which is great for complex joins across normalized tables. MongoDB uses MQL, its own query language focused on querying document structures, often relying on embedding-related data rather than joins.
Okay, structure and querying. What else?
Normalization. SQL databases typically push you towards high normalization, breaking data into many related tables to reduce redundancy. MongoDB often encourages denormalization embedding related data within a single document for faster reads, though you can still link documents. Transactions. As we said, SQL has traditionally had very strong, mature ACID guarantees. MongoDB now has AC2, but SQL systems have a longer history here. And scalability. MongoDB is built for horizontal scaling, sharding. SQL can be scaled horizontally, but it's often more complex than its typical vertical scaling approach.
So the guidance from the book is basically...
It suggests MongoDB shines when you need that flexibility, when you're dealing with large volumes of diverse or evolving data, need high scalability, and want rapid development cycles. Traditional SQL is often better when your data is highly structured. You need complex queries with lots of joins, and absolute data integrity through strict schemas and mature transactions is the top priority.
That's a really clear distinction. Useful. And the chapter actually shows you how to get MongoDB running.
Yeah, it gives you the practical first steps. It mentions a few ways to get it.
Yeah.
You can download the free community edition, run it using Docker containers, or use MongoDB Atlas, their managed cloud database service, which the book calls the most efficient option, likely because you don't have to manage the infrastructure yourself.
But for running it locally.
For local setup, it shows the basic command line stuff. You typically need to create a directory where MongoDB will store its data files. The default path might be something like data.java on Windows or data.java on Linux Mac. Then you start the MongoDB server process, which is called mongod, and you tell it where that data directory is using the DB path option.
Okay, start the server. Then how do you interact with it?
You use the client shell, which is now called Mongosh. You usually run this in a separate terminal window. If you just type Mongosh, it will try to connect to a MongoDB server running on your local machine on the default port 27017, and it drops you into a default database named test.
And the chapter mentions other default databases.
Yeah.
Admin, config, local.
Right. Those are mostly for internal MongoDB use. Admin is for server-wide administration stuff like users and roles. Config stores metadata for sharded clusters, and local stores information specific to a single server instance, particularly in a replica set, like the replication log if it doesn't get replicated itself.
Yeah.
Generally, you don't put your application data in those.
Good to know. And it shows how to make your own database and do basic stuff?
Absolutely. It shows the use your database name command. If the database doesn't exist, MongoDB creates it in memory, but it won't actually show up or be saved to disk until you insert some data into it. Then it walks through basic CRU'd examples: create, read, update, delete.
Like what?
Like using db.tasks.insertMany to add some sample task documents to a collection named tasks. Then db.tasks.find to see all the documents, or db.tasks.find to find a specific one, and db.tasks.update1 to modify a document. It also shows an update command being used for deletion in one figure, which is interesting, though typically you'd use delete one or delete many.
Okay, basic operations via the command line. But surely there are graphical tools, too.
Oh, yeah, definitely. The chapter lists a bunch of UI tools that make it easier to see and work with your data visually. There's the official MongoDB compass, others like Studio 3T, NoSQL Booster, even a MongoDB extension for VS Code, Navicat, and the Data Explorer built into MongoDB Atlas, if you're using that. Lots of options.
That's a good overview of the database part. Now, just quickly revisiting Node.js and Express.js, what were the key reinforcements from their sections?
For Node.js, it really just doubles down on that core idea, asynchronous, event-driven runtime using non-blocking I/O. The big takeaway is how that leads to high scalability, especially for apps doing lots of I/O. It also briefly mentions the Node.js REPL, the read evil print loop.
Interactive shell.
Yeah, you just type Node in your terminal, and you can execute JavaScript commands directly. It's super handy for quick tests, trying out language features, or debugging small snippets without setting up a whole file.
Okay. And for Express.js?
The reinforcement there is its role as that minimal and adaptable framework sitting on top of Node. It provides the essential web server features, especially highlighting the middleware architecture and the flexible routing system without forcing too much structure on you. It lets you build APIs and web apps more quickly than with raw Node.
Right, the scaffolding. And finally, Vue.js, what was the emphasis there?
For Vue, it reinforces its focus on building user interfaces and SPAs. Key takeaways mentioned again are its reactive data binding, how data changes automatically update the UI, its component-based structure for building reusable UI parts, and its use of a virtual DOM for efficient updates and good performance. And again, that ease of integration comes up as a major plus.
Wow, okay, so Chapter 1 really does cover a lot of ground. It introduces all the MEVN components, explains their roles, their main features, gives you a good feel for the whole stack, and that MongoDB DAO was quite detailed.
Absolutely. It does a great job setting the stage. You understand the JavaScript everywhere idea. You get a solid first look at MongoDB, Express, Vue, and Node, and you even see how to get MongoDB running. It lays that essential foundation.
Yeah, it definitely builds a strong case for why MEVN is considered, a powerful and flexible choice for modern web development. Performance, flexibility, developer experience. Those points come through, it gets you ready for what's next.
Exactly. It sets up the understanding of how these technologies are meant to work together.
And speaking of what's next, the chapter conclusion points towards prerequisites. Looking ahead in the sources table of contents, Chapter 2 is called Prerequisites.
Yeah, that's the logical next step, isn't it? Chapter 1 gives you the what and why of the MEVN stack. Chapter 2 is almost certainly going to be the how to get started, installing Node.js, maybe setting up MongoDB tools locally, creating your first project structure, getting your development environment ready.
Right, taking that theory and turning it into a practical setup so you can actually start coding.
Precisely. It's the bridge you need to cross to actually start building things with the MEVN stack, preparing you for the deeper dives into each component and the project work later in the book.
This whole introduction paints a compelling picture. The idea of using JavaScript for everything, front to back, combined with the flexibility of something like MongoDB. It's quite appealing.
It definitely is. And it makes you think, right? Consider the advantages we just talked about, the unified language, the adaptable database. Now think about an application maybe you've worked on before, perhaps using a more traditional setup like Java or .NET on the backend with a relational database. Based just on this introduction to MEVN, how might building that same application feel different with this stack? What kind of architectural choices might you make differently knowing you have JavaScript everywhere and that flexible document model? That's something interesting to chew on as you get ready to tackle those prerequisites.